Hey, Mickey, keep on road for later, yeah? Eyes low, blazing OG, you know me, the young trendsetter, force with me like Kenobi. Knowledge in abundance that can alter your mind. They say I speak to the youth, I tell them take your time. Cause why rush it? Everybody tripping over public perception. The way you better move in the best Benz, elect friends, get
Welcome back. It's been a little bit between videos and I'll address that a little bit later. But for now, let's just get stuck into some work. There's a few things that I said I'd cover in this video, and I will. However, overwhelmingly, the number one thing that people asked for was what sort of materials do I plan on using, and what sort of materials would be appropriate for this sort of thing. So today I thought we'd start there. We've done all of our initial prototyping in PLA. I've mentioned in the past that this is because it's cheap and easy to print with. As I mentioned earlier, these are just printed from PLA. It's cheap and easy to print with. See, told ya. But what about the final product? Well, it gets pretty damn hot in Australia, especially in the summer, and it can regularly get above 40 degrees C in Melbourne, and inside car temperatures can exceed 30 to 40 degrees hotter than the outside temp. Again, I'm going to stop for a second to remind you that material science is a discipline in and of itself. So what I'm going to mention here are simplified explanations, but ultimately with the same outcome. The glass transition temperature of a material is basically when it transitions from being a hard, solid state to a soft, rubbery state. When printing, we generally greatly exceed the glass transition temperature and reach the melting temperature in order to perform our print operation. Then, obviously, the part cools below the glass transition temperature and becomes a solid again, thus allowing us to create something like this Centerlock spanner. But the glass transition temperature is still lower than that of the melting temperature. Ever heard someone say jet fuel can't melt steel beams? It's a litmus test. Anyway, that's not the proof it was a setup. So you can see this one side has failed under load as the heat reduced its strength by exceeding the glass transition temp. And we can see the other side without the heat application is obviously fine. Get it? So if we conservatively estimate a 30 degrees C day in Melbourne, add 40 degrees C, we've already got an inside car temperature of 70 degrees C. The glass transition temperature of PLA is typically somewhere around 55 to 65 degrees C. Not only that, but PLA is not UV stable, meaning that the UV from the sun will begin to degrade the print, so it would need some sort of coating, paint or sealer to prevent that degradation. Basically, this means it's no good for the faceplate. We could potentially use it for the section housing the hardware inside the dash, but the only advantage of this would be to maybe save a minimal amount of money. In my opinion, not worth it. However, I'll stop here for a second to show you this that I made for our tattoo studio. This chandelier is completely printed from regular old PLA, which I printed in multiple sections, painted, and has been hanging in our tattoo studio for over 2 years. It has suffered a little bit of warpage, which I did expect, but I also wanted to test for myself what the weight and heat fluctuations would do to something like this. If it was a complete failure, I was prepared to make another one from a different material. My point is, don't be afraid to try things. Okay, back to materials. PETG would be an appropriate material. I designed and printed these brackets over 3 years ago, back in 2022, and they've been on the car since. They've seen snow, frost, rain, consecutive 40 degrees C days, and everything in between. They're uncoated and exactly how they came off the printer, and work just as well today as they did the day that I made them. However, PETG is generally of a glossy appearance and also not easily paintable. Neither are things I want for what I'm making. Yes, I am aware that you can also skin parts with fiberglass or carbon fiber rather than painting. Don't worry, I've got some plans for that coming up in the future, but it's not suitable for this job. ABS is a good choice as it has a higher glass transition temperature, around 105 degrees C. Like PLA though, it is also not UV stable, however it is easily paintable. It's a little bit harder to print than PLA and PETG, but not a big deal if you know what you're doing. ASA is basically all the same features as ABS, except it is UV stable, has a similar glass transition temperature and melting temperature, paintable, and generally will suffer less warpage due to heat. Probably at this point it's the front runner. These have all been FDM materials that I've been discussing, but there is also... hang on. FDM, what's that mean? FDM, or fused deposition modeling, is a process by which usually a thermoplastic is melted and extruded through a nozzle to create the part. It functions essentially the same way as a hot glue gun, except it's controlled by a machine and not some Z-grade how-to instructor on a Facebook video.
Got it? Okay. No.
So as I was saying, these have all been FDM materials that I've been discussing, but there is also the potential for resin printing. Hang on, what's resin printing? With resin printing, you're capable of achieving better detail than FDM printing. It's a process technically called stereolithography, and a UV light is used to cure the liquid resin in selected areas. The part then rises out of the bath as each layer is completed. As the parts are UV cured, we don't need to be concerned with UV degradation over time, so we could potentially use the raw parts, which means unfinished or uncoated. We'll get more into this later, but due to the nature of the process, it takes the same amount of time to cure the entire build plate as it does to print one dot. Thus, the main time limitation is the height of your model. It's also much messier to print with than FDM, painful to post-process, and generally speaking have much smaller build plates. There are bigger printers available. These printers are about 6 years old and somewhat outdated by today's standards, and they also have relatively small build plates. If I was to split components even further down, I could obviously make them fit, but then there would be more assembly involved later and potentially more post-processing as well as potentially noticeable join lines. I especially don't want this for the faceplate. Remember, I want it to look like the OEM one, not like it was made in 10 different stages. Finally, we need to consider the orientation of the print and the trade-offs. 3D printing is perfect for printing complex geometries in one piece, often creating one-piece components that are unachievable with subtractive manufacturing methods like machining on a lathe or a mill. One such example is NASA 3D printing rocket injectors, and I'm going to quote straight from their website here. Traditional subscale rocket injectors for early SLS acoustic tests. SLS is selective laser sintering. It's essentially metal printing. Similar to SLA or resin printing, the material is usually in a powdered form, and again a laser is used to selectively melt the material and make the part. This also requires a lot of post-processing, and it is prohibitively expensive for a hobbyist. However, it can be viable to outsource, especially if you're only looking to do ones or twos or a small batch run. You pay more per item, but you end up saving money overall because you don't need so many parts. Anyway, suffice to say there's a fair bit to it. It's enough for now. We'll get back to this at a later date. Back to the article, and blah 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 blah. They basically managed to make them in 3 weeks instead of 6 months, and for half the cost. Cool, right? Now let's have a look at some slicing software. There are a lot of options, and paid ones are definitely not necessary. Horses for courses. We also need to consider the aesthetics of the print orientation and layer lines, but those lines will also be a factor in surface finish and also strength of the part depending on the direction of load. Orientation of support structure will also affect the print time. You may only be printing bespoke items, in which case print time may not be too much of a concern to you, but if you're looking to print multiples, it quickly becomes an important trade-off. For prototyping, quick print time is generally important to me, as I like to be able to iterate designs quickly. Similarly, if I know that there's only going to be really one orientation that's going to work for a print, I'll plan my design accordingly so that when I do print, I can achieve the best possible trade-off between surface finish, print time, and assembly complexity, depending on the job. Right, so that's all well and good, but how am I going to translate that information into the switch panel design? After some thought and consideration of all the points I mentioned above, I've decided to try this. The indicator lights will be clear resin. My switch covers will likely be a black resin. Originally I was just going to use the OEM heater control toggles, but I think I'll remake them as well so that everything matches perfectly. And at this stage I think everything else will be printed from ASA on the FDM machines. Alright, quick little interlude. I get a fair few messages and comments from people basically asking about something to the effect of a Patreon account and if I'd consider doing something like that. I honestly have avoided that for quite a while, I think mainly because I want to make sure I can actually offer enough to make it worthwhile for you. However, I am at something at a bit of a crossroads. I still work full time, we have the tattoo studio, a young daughter, trying to run this business, and these videos take a very long time. I have 1,000,001 ideas for things I want to make and show you, and there's only so many hours in the day. So I've put something together on my website that'll allow you to sign up and help support the channel, and ultimately help me justify spending more time doing this and less of other things, which will mean more videos and content for you guys. The summary is essentially I'll be offering early access to the videos, ad-free, as well as some exclusive content and regular downloads, which may be printable files, engineering drawings, and other relevant things to the channel, as well as discounts on the store. And I'll add to what I offer over time. I preemptively set up a Patreon account, but I'll be closing it in lieu of this. In regards to the subscriptions, I'm also happy to consider anything you guys might want to see be made available. I was considering offering something like a tutoring, mentoring service, but you can let me know in the comments below if you'd like to see that or something else. Anyway, that's it. Let's get back to it. So now that I've decided on materials for the switch panel, it's also time for me to start making some changes to the design that we identified in the previous video, as well as some that I didn't mention. However, the main priority is still first to get the car registered again and ready for the turbo setup. In order to do that, I probably should put the rest of it back together and tidy up some areas that need attention. Seeing as I've got the grille off, we'll start with this bolt that quite honestly has sat like that since I put the car back together for the first time in 2015. So obviously 10 years later was the time to fix it. I did know these rubbers were on the way out, and I actually made a design so that I could print some, but then I found these other ones that I already had in my stash of parts. I decided I might as well use those first. Waste not, want not. Ah, the boot lid. Classic KE25 rust spot. You'll remember how we got to this point, right? Okay, so that was part 1. Probably time now for part 2. Honestly, it almost feels like I should just try and reskin the whole lid, but I'm going to start with some patch panels. I need the practice anyway. At this point I have no idea how this badge comes off, so naturally, in spending way too long trying not to break it, I broke it. I'm really not sure how extensive the rust is under here, and I also really don't want to get stuck into doing extensive panel work right now. Mentally, I need to draw a distinctive line that says good enough for roadworthy, because my speeds are 0 and 100, and otherwise I'll be here for 2 weeks trying to make the perfect panel, and that's not the current priority. There's a couple of rust converter products that I wanted to try, and I can assure you none of these are sponsored. I've had really good success with the liquid evaporust product that you soak parts in, so I wanted to try this one. It's basically a gel that allows it to cling to the surface so you don't need to submerge the whole part. It was a little hit and miss here, but I wonder if it would have worked a bit better in some spots if I loosened up the oxidation with a wire wheel or something else first. Anyway, for now I'm going to find and hit all the rust spots I can with this 2-in-1 rust converter and primer. While I do that, I keep reminding myself that I'm not cutting corners and that the priority right now is roadworthy. You might also remember from the previous video that something else on the list is both adjustment of the distributor and a custom clamp. It was at about this point though that Angelo told me he had absolutely nothing at all to do and would love to have my terrible car in his workshop. But seeing as we're in Corolla mode, it was probably the perfect time to give the KE70 a bit of love as well. I think at this point it had been sitting for at least 6 months. Oh hey.
I'm like super keen to see which one's faster.
I think which one's slower is more appropriate than which one's faster. I've got what I think will be some cool little road tests coming up, but you're going to have to wait for those until we get these cars looking a little bit more respectable, both superficially and mechanically. First on the list is fixing that ride height, and we're going to start with the rear. I'm not going to dwell on the Makita special springs and the average shocks right now. This assembly is all coming out soon anyway, but this will do for the meantime.
Handmade or something.
And just like that, it was already time for a morning snack, so we took Angelo's race car. This was a factory 3.9 Rover V8, but it's now been stroked to just a slightly bigger 5 litres. Seeing as the wheels were off, I thought I might as well give them a quick clean and a little forearm workout while I was at it. Don't worry about stool leg curls, some spray bottle pumps are all you need.
Squeeze extra hard instead of just muscle it.
We've also got Angelo washing a special something in the background there, and we'll get to that soon. So these are what I believe to be AE86 stubs with coilovers and camber tops. We're going to give them a quick little once over as we reassemble them. Quite a lot of this car will be getting some better attention in the very near future, but for now we'll just give it a little tidy up. Everyone I know.
I was pretty salty about that. It's going on fucking great.
True, correct. They
Uh-oh. Actually, someone called me a gooner, and I was like, what does that mean? The funniest thing I reckon I've heard all year.
The bleeders on both brakes needed some love. One of them was actually broken when I got the car. It was nice to finally be able to sort that out and then flush and bleed the brakes. Time for the big reveal. Now we're looking a little better. Great, so now we'll just start it up. I'm pretty sure the solenoid on the starter motor is cooked, but that's a problem for future Ryan. We'll have to pull one off one of the other cars, and it's KE25 time anyway. That's pretty un-Australian, so we're going to have to bookmark that and come back for some redemption later. So I made it up to the workshop, and I've got to say it felt pretty good to be driving the 25 again. First things first though, there's a bit of an oil leak from both the sump gasket and the drain plug, which you might remember me mentioning in the previous video, but there's also another leak, and I'm also pretty sure I know why that is, but we'll clean it up a bit first and have a look. No, that's right. Oh, how'd you get that off? Good job. So, in classic Ryan fashion, I got distracted while filming and assembling the timing case and forgot to clean the sealing surface of the crank pulley after painting it. As you might be able to see, there's some mild surface rust and imperfections on there, which was causing the seal to not seal. Next, we've got to change the sump gasket, and all I can say is I would highly recommend not doing this with the engine in the car if at all possible, and certainly not without a hoist. It's thoroughly unenjoyable.
Amazing. That's oily.
Yeah, cool. It's all the torque from that engine, that's what it is.
Yeah, certainly.
It's powerhouse. Once we got the sump off and had a proper look at the drain hole, it became pretty obvious why it would never seal. Someone has dented it right between the mating surface. Best guess I can think of is someone trying to chisel off an old drain plug maybe. Either way, it's a job for another day, and I'm going to swap to this spare sump that I prepared earlier. Luckily, K engines were worthless for basically the last 30 years, and I've managed to collect a few of them. A little bit of 2-in-1 rust converter and primer as a base, then some high temp satin black over the top. The internals look good at a glance, and we'll use some silicone on both where the block and the timing case meet, as well as the corner of the half moon for the crank. This diff is actually a shortened VL turbo diff, which is a 28 spline Borg Warner as opposed to the standard 25 spline. More spline, more stronger. It's obviously been converted back to drums because the VL turbos are discs, and it has kept the 4x110 stud pattern. Any LSD center from a VN up to VT Series 2 when the LS1 came out will fit your VL housing, and that's what I've got in here. Some other trivia is that a standard is a 2-pinion center and the turbos are a 4-pinion center. We'll come back for a proper diff explanation at a later date. Yes, I am committing a sin on camera here. I know gaskets for this exist, but today it's getting a little bit of silicone. I did not plan ahead for this.
I'll wash it.
Ah.
Oh.
You know what I can't get out of my head? Is the idea that I need to buy an NSX. Shocks are next. I'm pretty sure that these were honestly not great when I put them in the car about 10 years ago, so I imagine they're even less great now. You know something really inconsequential that always drives me crazy? When a bolt is too loose for the ratchet to slip backwards, but too tight to do with your fingers. Yep. He's dead, you don't know.
I do know.
You don't? No! You can see this shock is not too bad, but then there's this other one, not the best. You can see here the wheel cylinders are also shot, and while I'm here I'm also going to replace this hard line because both nuts are damaged. I've got a different diff and gearbox that I'm planning on putting in the KE70 soon, so we'll probably cover the function of the diff and drum brakes when I clean that up, so we'll push on for now. Similarly, I will address this further when I change the brake master from a single to a dual line, but we need to make sure that we either get the same replacement cylinders or ones that give us basically the same ratio from the master to the slave. It's a hydraulics thing, we will cover it. Plenty of life left in these shoes as well, so I'm just going to scuff them up a bit before putting the drum back on. I made up this line literally years ago, so it was nice to finally use it. It was a little long in the end though, so I had to cut it a bit shorter. Oh yeah, that's not bad, eh? Here we are just flaring the end that I cut. We'll cover this when I cover brakes, I promise. Probably should give you a quick squeeze at a couple of the other cars that are kicking around in the background here as well. This is an Austin Ute and they're cool as hell, and this series was originally a 4-cylinder L-head and now has a 4-litre Rover V8 with 5-speed, 24-spline diffs and disc brakes. Okay, now it's time to address another problem which has been around a while, the access hole for the brake adjusters. As you can imagine, as the pads or shoes wear, the position that they'll need to be in will change. Not only that, but when we've got everything nice and set up in here, if we had the pads in the ideal spot, we wouldn't be able to get the drum back on because the shoes would contact the face. So we've got to have them wound in a bit, put the drum on, and then we need a way to wind them back out, hence the access hole. Because these drums have been re-drilled from 5-stud to 4-stud, the pattern and position of the hole is obviously different, hence the need to re-drill.
Oh dude, this is pretty sick actually. Forward and reverse.
Is that your new Christmas present? Yep. Time for lunch, so we pulled Angelo's MG Midget out for a little cruise. It was originally an 1100, but now it's a 1300 stroker with twin SUs and a cam. Perfect. Now that the brakes are done, it's time to flush the fluid that's been in there for longer than I care to imagine, and then also the clutch fluid, because this car actually has a hydraulic K-to-T bell housing with a T50 gearbox from an AE86, where normally it would have a cable clutch like the KE70.
Yeah, that's the one in the city.
That's... Yes.
You get up, see what happens, and
It's not. You have to add castor oil to the... Hi Ryan. I know that you're having a lovely time. I'm also having a lovely time.
Correct.
Regards, Jessica.
Correct. Those guys think of everything.
Do it so that you can turn it halfway. Sanko said Merry Christmas, y'all, and it triggered you. Yep.
Lead not on properly.
Yeah, I think so.
Even with the free account, I have these two downloads there for you, one of which includes the toggle switch cover,
They talking about careers like you need them and they urgent. These kids are barely 6, 17, man, they virgins observant. The pressure put in our seeds to get straight A's. I know I was rushing home just to get straight Blaze. You know the age, naivety, frustration and rage. Suicide rates constantly raised and I'm amazed. Graduating, maybe you can work the rest of your life. Education for some dreams and aspirations aside, y'all get the picture. These kids are falling victim to a system, raising money hungry in a food scarce prison. And when that prison is the building blocks for a whole generation, it takes someone great to instigate some separation, know what I'm saying? So stand alone, fucking stand tall, dog. You can always get up higher than you fall, dog.